Hi, good day everyone. I'm Haziman Zakaria and I'm here on behalf of my team to present our research project Safeguarding PU Air Filter Production, Design Innovation for Risk Management for INNOPLEN 2023. Allow me to introduce my research team, Mr. Faiz Azizul and Associate Professor Dr. Yudi Fernando from the Faculty of Industrial Management, University Malaysia Pahang. We are also joined by Dr. Diyana Kamarudin from the Faculty of Education and Liberal Studies, City University Malaysia. Our research was conducted at HBZ Sdn Bhd, a leading OEM in Malaysia specializing in auto filtration system. We have identified a critical issue, which are the effectiveness of the high-rate method in their PU air filter production line is unclear, especially due to the hazard from the manual trimming process. Although the company has implemented some hazard control strategies, such as rest interval for the heat stress, significant risks like injury from the sharp cutter in the rework process persist. This is a high priority risk that need an innovation solution. The company inability to conduct a root cause analysis is due to the high operation load, further emphasize the need of our research. So in this study, we aim to achieve three specific objectives, which is we want to analyze the current practice, designing the engineering control, and risk assess and do an economic analysis. So our research methodology combine the PDCA model, known to fostering continuous improvement and the engineering design process, empathizing a systematic and methodological workflow. So this combined approach set a stage for a throughout analysis leading in the inputful finding. So our first finding is the hazard identification from the reconducted HIRAC. So the most critical risk is identified is a hand injury, scoring 9 out of 16 marks, marking it as a high priority risk. So this is a primary due to the use of the sharp cutter. So we aim to reduce the assessment to 6, which is to downgrade it into the medium priority risk. So what we do is we develop the three conceptual design, evaluating them using the part method, and selected the design 2 as the best option. So design 2 then was converted into a three-dimensional design using the CATIA software. So the right side of this slide show that the full assembly process example. The full bill of material for this model is also displayed here. Next, we employed the embodiment design process, producing a parametric design and product function correlation for all part of the model, developing an optimal design layout for the further detailed design. After that, we conduct a simulation analysis of critical part to ensure the reliability and the validity of the design. So this slide shows the summary of critical part analysis and some example of generative structure analysis of the cutting blade part to assess the material strength. Finally, we conduct an economic investment analysis to assess the feasibility of this design replacing the current practice. So the rough estimated production cost for one machine is around 4,530 ringgit with an ROI of 250%, cost saving of 0.04 per pieces, and the payback period of 3.4 years. So, in closing, the risk management method we propose today hold the promise for enhancing safety, efficiency, and ultimately the sustainability of the PU air filter production line. By embracing this innovative design and risk management approach, companies like HBZ Malaysia Berhad can mitigate persistent hazard, improving both the welfare of their workforce and the bottom line. We look forward to seeing our design concept implemented and to do a safer future in the manufacturing industry. So thank you for your attention, and we welcome any question you may have.